to clipboard from our public IP address here and paste it into a new tab and hit enter. And we're browsing the web server that's running on our virtual machine, as we can see here. Now, if you don't see this, make sure that you wait an appropriate amount of time so that the cloud init configuration can finish setting up the virtual machine. And once that's done, you should see this. Now, let's go back to our virtual machine real fast. And what we see under settings is we can manage our network settings here. You see we have our network interface, the effective security rules for inbound, outbound, and if we had application security groups and load balancing, we'd see that as well. And we have our virtual network and subnet here, and we have our public IP address and our private IP address. We also see we have some connection settings here, which tell us the various ways to connect to our virtual machine. We have our disks that we can manage here. We see our OS disk and our data disk. Now, we don't see our temporary disk because this is a localized resource to the underlying hardware. So simply, when we are using a virtual machine, we're not going to be able to manage that. Alright, gurus, so we've covered everything we wanted to cover for our demonstration portion of this lesson. Let's make our way back to the slides for a quick review of the key takeaways from this lesson. Okay, gurus, so the key takeaways here are that virtual machines are used to provide Linux or Windows style computing, and we can migrate our existing workloads from on-prem into Azure VMs, for example, moving our web server on-prem to Azure VMs. And with virtual machines, we can provide cloud computing solutions that are highly available, fault-tolerant, scalable, and elastic, which we will cover more on later. Now, the key components for our virtual machines here are the CPU and memory, which is determined based off of the sizing, the associated networking resources that we need to use, such as virtual networks and NICs for our virtual machine, and our storage solutions using Azure Disk to provide the storage for a virtual machine. Now, a bonus tip here for you is that the security for VMs, as we saw, can be managed by opening ports on a network security group to provide public connectivity, and that's something to keep in mind with your virtual machines. Okay, gurus, so that's everything I have for now. Thanks so much for joining me in this video lesson. I look forward to seeing you in the lessons to come. Hey, and welcome, gurus. I'm Chase, your Azure Training Architect, and in this video lesson, Managing Virtual Machine Disks, we're going to be talking about what virtual machine disks really are. And then we're going to go through a demonstration where we're going to attach a virtual machine disk and then enable encryption on it. So a virtual machine disk, i.e. Azure disks, are really just virtual hard disks, and virtual hard disks are just a file representation of what we find on a hard disk. So in the physical hardware, we have physical hard disk drives, and with the virtual machines, we have virtual hard disks that virtualize that hardware component. Virtual machines use these virtual hard disks to store data, and our virtual hard disks, i.e. Azure disks, use the underlying Microsoft storage infrastructure and store these disks as page blobs inside of the blob service. Now, the purpose of Azure disks here is to provide us storage for our virtual machines. And this diagram clearly lays it out here. We have our OS disk, our temporary disk, and our data disks, and these are our Azure disks for this virtual machine, and it uses the Microsoft storage infrastructure to store these disks as blob storage. Now, we get from this our OS disks, which come by default with our virtual machines, and these store our operating system and are the root volume for our virtual machine. Then we have our temporary disks, and these come by default as well with our virtual machine and store non-persistent data and can be used for page and swap files. And these disks are localized to the underlying hardware from where our virtual machines are deployed on the Azure infrastructure. Then we have our data disks, and these are disks that we can attach. They don't come by default to provide persistent data storage for things like files or databases for virtual machines. And when we're talking about disks, there are two different types of disks. There are unmanaged and managed disks. Managed disks are those that are in Azure Resource Manager managed resource. And unmanaged disks are not managed by Azure Resource Manager, so they are not a top-level resource. And with our managed disks, these are managed for us inside of a Azure storage account. And then with the unmanaged disks, we have to manually manage these disks inside of our own Azure storage account. It's not going to be managed for us by Azure. And with managed disks, availability is supported by default because we don't have to manage the disks, and Azure, i.e. Microsoft, is going to take care of all of that for us to make sure that the availability is built in. Now with our unmanaged disks, this availability is not guaranteed, and that's because the nature of how Azure Storage Service works is not going to guarantee that we are always making sure that each Azure storage account is on different underlying hardware. So it's best to go with managed disks. And they also provide role-based access control and snapshot support, as well as backup support for our disks. Now the major disk types that we have are UltraDisk, which is for I/O intensive workloads. Then we have premium disks, and these are our production and performance workloads. Then we have our standard SSD, which provide us good disks for web servers and light enterprise apps. And then we have our standard HDD disk, and this is great for backups or non-critical workloads. So what we really have here is our high performance SSD and all the way down to our standard SSD. And then we have our hard disk drive here, our HDDs. Now, we can encrypt our disks, and the disk encryption can happen at rest, and also it can happen on the virtual machine, and this provides us a defense in depth with our disk encryption here. The storage service encryption is the encryption of the physical disks in the data center, which is encrypting the disks of the underlying hardware, and this is built into the Azure platform. We don't have to worry about any of this. Now we can enable what is known as Azure Disk Encryption, and this is an optional encryption for our virtual hard disks, which ensures a disk is only accessible by the VM that owns that disk. And this is done using the OS tools like BitLocker or dmcrypt for Linux. Now, what we're going to do for our demonstration here is we're going to add a data disk to a virtual machine, and then we're going to enable Azure Disk Encryption by creating a key vault, creating a key in that key vault, and selecting the encryption settings for our disk. And then we're going to use the PowerShell to validate the encryption of the disk that we just created. So let's make our way over to the Cloud Sandbox and get started. Okay, Gurus, so here we are inside of the Azure Cloud Sandbox, inside of the Cloud Playground. And the very first thing that we need to do, like we talked about, is add a data disk to a VM. So we need to make our way to the virtual machine service. We can do so by coming up to the search bar here and typing in virtual machines. And then we'll select it from under services. And we see here I have an existing virtual machine that I'm going to be doing this on. Now, if you haven't already created a virtual machine, please take the time to do so now. If you need to learn how to do so, make sure to refer to the previous video lesson to do so. If you already have your virtual machine existing, then all we have to do is click into the virtual machine here, and then go to disks under settings. And we're going to minimize this blade. And what we see here is we have our virtual machines, OS, and data disks available to us. We don't see the temporary disks because, again, these are localized to the underlying infrastructure. Now, what we want to do is create and attach a new disk here. So we'll click Create and Attach a New Disk, and then we're going to name this disk, and we're going to call this our Cloud Chase disk, and you can name it whatever you'd like. And then we're going to leave all the settings for storage type, size, and encryption and host caching default. And we're going to click Save up here, and it's going to create that disk for us. And once it's successfully created the disk, as it has just done, it's going to update that virtual machine by attaching that disk, and this should take about 60 seconds or less for it to finish. And we see there it's updated the virtual machine, and it has attached this data disk to the virtual machine. Now what we need to do, that we've created the data disk, is enable Azure Disk Encryption by creating a key vault and creating a key and selecting Azure Disk Encryption as part of our encryption settings. We can do so by clicking on additional settings up here, And we can choose to use Azure Disk Encryption to encrypt OS disks, data disks, or OS and data disks. We're going to use just data disk here. And then what we're going to do is click to select a key. And we don't have a key vault, so what we're going to do is we're going to create a new key vault here. And we're going to name our key vault something unique. So I'll call this my Cloud Chase key vault. And make sure to use something that is unique, and you'll get a check mark letting you know that the name you selected is unique. Then what you're going to do is click next into access policy and make sure to enable access to Azure Disk Encryption for volume encryption. And then we're going to click review and create, and once it validates that deployment, we'll click create, and this is going to create our key vault. Now the next thing that we'll have to do once this is finished is create our key. Now this deployment for our key vault may take some time, so we're going to use some movie magic to skip ahead to when it is finished. Okay, Gurus, so we're back, and our key vault has finished provisioning, and now what we need to do is create a new key. So we'll click create a new key here, and we're going to give our key a name. We're going to call this our disk key, and we're going to leave the key type, the RSA key size, and we're not going to set an activation or expiration date. We're just going to click create. And this is going to generate that key for us inside of the key vault we just created, and then it will give us the version of the key. So we're going to click select, and now we see that it has updated our disk encryption settings with the key vault and key that we just created. We're going to click save, and it's going to update our disk encryption settings for our virtual machine, and this is going to encrypt the data disk we just created, and then we're going to validate this using the Cloud Shell, specifically PowerShell inside of the Cloud Shell. Now, if you haven't created Cloud Shell environment yet, you just click on the Cloud Shell icon up here, and you'll be prompted to provide the additional settings for creating a Cloud Shell, which is creating a storage account and then creating a file share to attach to the Cloud Shell inside of that storage account. That's outside the scope of this lesson, so what we're going to do is take a brief pause to grab a cup of coffee and come back whenever these disk encryption settings have finalized. Okay, Gurus, so we're back from our quick coffee break, and it looks like our disk encryption settings have finalized for Azure Disk Encryption on our data disk here. So to validate this, what we're going to do is we're going to open up our Cloud Shell, and we'll clear up our display, and we're going to run this command here, get az VM disk encryption status on our resource group here and on our virtual machine. So this is going to get that disk encryption status of the disks on this virtual machine inside of this resource group. We'll hit enter, and this is going to return to us whether or not our OS volume is encrypted, which we see it is not encrypted, which is correct because we only wanted to encrypt our data disk. And we see our data volume encrypted here, and it says it's not mounted, and that's because we have not mounted this disk even though it is attached. But what we're looking for here is our progress message that says encryption succeeded for data volumes. So for this data disk that we just encrypted, we have successfully completed the demonstration. Now let's make our way back to the slides to take a look at some key takeaways for this video lesson. Okay, Gurus, so the key takeaways here for exam tips are that Azure disks are really just virtual hard disks, a virtualized hard disk much like a physical hard disk on a physical machine. And we use underlying page, but we means. Alright, Gurus, that's all my time for now. Hey, and welcome, Gurus, to this video lesson. I'm Chase, your Azure Training Architect, and what we're going to be learning about today is configuring virtual machine high availability and scalability through the use of virtual machine scale sets and virtual machine availability sets. So let's get right into it. The first thing that we need to know is that we can use Azure's global infrastructure to provide highly available solutions. For example, inside of the Azure Cloud, we have regions across the globe where we deploy our virtual machines. But more specifically within these regions, we have a cluster of availability zones, and these availability zones are isolated from one another. And what I mean by that is you can think of these as their own data centers. They have their own power, networking, and cooling, and are standalone from one another. And this is fantastic because if one of these availability zones experiences any sort of outage, for whatever reason, like a natural disaster or some sort of apocalypse, like a zombie apocalypse, well, we know that we are good to go because the other availability zones are still available. Cool. So while the zombies are reigning terror on the world, we can rest assured that our solution is still good to go. While I think we might have bigger problems if that happens, I think it's unlikely that it will. So, something else we need to keep in mind is that even with availability zones, if we distribute our solutions improperly, such as putting our database tier in one availability zone, in our web tier in another availability zone, well, if availability zone 2 experiences an outage, well, our solution is ultimately still down and not highly available because it is not redundant. Now, what we could do to fix this and make it highly available is to spread our web tier across availability zone 1 and 2 and do the same with our database tier. And that way, if we experience that outage in availability zone 2, the good thing is availability zone 1 is still up and running and our solution is still available. Now, what we've just done here is known as a multi-easy deployment, and it protects us against availability zone outages, as we just saw. But what about protecting ourselves on the underlying hardware inside of these availability zones? Well, that is where virtual machine availability sets come in. And the purpose of availability sets is to protect redundant virtual machines on the underlying hardware, and specifically to protect them against host failure such as a server rack going down, and to prevent any sort of outages related to some maintenance activities. Now, to take a look at how this works, let's say we have our 2 server racks here, and each of them is in their own fault domain. And the fault domain is going to protect us from underlying host failures because these 2 server racks don't share the same underlying resources like power or network. So if there is that power or network outage and say fault domain 2 goes down, well, fault domain 1 is still up, and availability sets automatically takes care of this activity or any updates occurring on the under outage will machine both as part of an availability set. Well, if server rack 1 goes and we have domain host failure inside of our availability zone, let's say we have 2 server racks and we have our app running and both as part of it is still just a moment. Cloud chase AV set, and I'm going to deploy this into the default region Central US for me, and you can use many. I'm going to leave the default of 2 and 5, and I'm going to deploy this into the default region Central US for me, and you can use whatever region you'd like. Just keep in mind the virtual machines that you want to put into the availability set. And we can update domains. Provisioning, view, and create. It will validate the 2 and 5, and we're going to leave the rest of the default select and click review and create. It will validate this deployment. Once it's passed, click create, and this shouldn't take this. You cannot do this the same way we've done this. After it's already been provisioned, you have to delete it and recreate it to put it in the hub. Is select set. It must be done upon create tool machine inside of an available. Okay, gurus, so we're back that we have, and we can continue to these sets. See you in part 2 of this lesson where we Hey, and welcome, gurus, to part 2 of this lesson where we're picking up from the last lesson where we covered our availability set. We're going to be talking about how we can provide scalability for whenever we can ensure that costs by automatically using these auto scaling features of virtual machine scale sets. Now, the components of a virtual machine scale set are the VM definition, and the VM definition defines created if we have CPU utilization that is greater than 80%. We'll then add one policy allows us to scale back in and delete VMs by priority as scaling operations occur, and this can be used to provide a scalable and elastic solution using these virtual machine scale sets. And this is a lot like when we create our virtual machines. We'll name all of those the image. We create a virtual machine. We can choose our machines to communicate with the internet. Here, fixing the scaling. And take a look at this. This is where we can define our scaling policy. How many initial instances do we want to exist? Say we want it to be just one. And then we can choose our scaling policy. We can manually do this and manually have to scale out, or we can set a custom policy. It says the minimum number of instances we want to have in our scale set is 1, and the maximum we want to have is 10. And what we want our scale out to take place on is the CPU going to %. We also see we have our scale in policy where we can determine how we want to scale in and what will take priority. We can choose to scale in the VMs with is where we can set our upgrade policy. As for our, it's really great if it's behind a load balance. Some data in cloud create, and let this go ahead and validate, and then click create, and download the private key and let it create the resource. And this is going to create our scale set for is the scaling configuration that we quick review of this lesson. Okay, so use scale set virtual machine solution. Seeing you in the lessons to come. Hey and welcome gurus, I'm Chase, your Azure training architect, and in this video lesson, automating virtual machine deployments, we are going to be talking about all the ways that we can automate deploying our virtual machine solutions. But before we get into talking about that, we're going to talk about why we might want to automate our VM deployments in the first place.